And we're actually going to, at this moment, start going into our next topic, which is architecture and components. It's like Legos, but for building stuff our customers use. I really do look at Azure components and services Legos from an application architecture and composition perspective. Who in here has heard of microservices, nanoservices? I just made that one up, but really small microservices. It's when we're thinking cloud, you now have to stop thinking about the traditional methods of doing things. Yes, I could put this on a server with Windows on it, with IIS, and deploy it out and scale it like I normally do. But we're going to talk about a lot of the architecture bits that we can really leverage the power of the cloud to think beyond that. So you're going to think small, little, bite-sized chunks that can work together to build really powerful applications. We actually used a couple of different ones in this application. We're going to go talking about it. So, yes?
The UI, when they showed us, you use the index.html, part of the UI.
That's it, yeah.
Nothing else.
Nothing else. Well, I lied. It does use a couple other things, but we're going to talk about it right now. So the client that you guys saw out there, so the voting app has two parts. It has the client and the back end. Okay, the back end are what's processing the votes, and the front end is what's giving us that page. Thinking about the client, and again, I'm thinking components here. I'm thinking, how can I piece this together to make this go out quickly? I want to optimize my cost. I want it to be secure. I want it to be reliable. And your four pillars of architecture when you're thinking cloud: reliability, security, performance, and cost optimization. If you take nothing else away with you from this morning, those four things, four pillars are super important. There's a paper written by AWS, which is a great paper for cloud architects, called A Well-Architected Framework. Talks about those four pillars. The four concerns that you have are security, reliability, performance. Now I forgot the last one. I'm kidding. Cost optimization. Cost, thank you. So in the client, the first thing that I said is, well, the client itself is really a single page. It's an index.html and two really small JavaScript files. One to cast the vote. These are both jQuery files. When you click a button, it sends your vote to the back end based on the button that you clicked. The load results is when we refresh the page, we're kind of showing that tally of votes. So we're going and getting that information displaying on the page. Those are the only dynamic aspects of the page. And that's all that it was. So I said, I've got two statics files. I don't need IIS. Heck, I don't need an entire Windows server to serve these things. So how can I do this cheap, that it'll scale, be secure? So blob storage, it's an object. It's a file is an object. I put it up there. And that's what our release did, is it just updated those files and pushed them to the blob storage. No servers, no spinning stuff down, no spinning stuff up, done. To date, we'll go back and check, but I checked last night, my cost on storage is still 0 cents after running this for 5 days. 0 cents. $0, 0 cents for storage so far in the last 5 days. I'm using so little storage that Azure hasn't cared. No. If you look at the actual cost, I've got to go back through the pricing on it, but you're measuring gigabytes. We're barely using even a megabyte that's out there, right? So this is probably going to run for about a month before I get charged a penny. Something like that. And that's also depending on the type of storage that you use, which I did it on the cheap. Yeah, and consumer pricing as well too. Then I also and again, I didn't do anything with Azure for this part, but somebody asked me what other components I used. Well, I used Bootstrap for the styling and the CSS that went on there that gave me the structure, the color, the buttons, things that I didn't have to do. I used Bootstrap CDN to pull that down. I'm not going to host that. Let Bootstrap host that. They're already doing it. Google hosts that. Use that. I used jQuery. I think I used also Bootstrap CDN on that, and I think they use Google's is what they end up using on it. Cool. Underscore and JSON2, these were two other JavaScript files that are commonly used in building front ends with jQuery and Bootstrap. So I pulled them down and I used Cloudflare's CDN. I'm not going to host it. I'm not going to pay for it. Let somebody else do it. We use that. The other thing too that we didn't see yet, but we'll look at it here, is also use Visual Studio Application Insights. So I put a little snippet of code from Azure Visual Studio Application Insights to track my client performance. So I can see how many page loads I'm getting, what the load times are, if this thing's performing or not, is it live, am I seeing any errors? That's coming out from there too. That's my client. Now, it was all done in one page in 2 JavaScript files that I wrote, but it's using all these other components. I will pay for these. This is free. This is free. And so far, that hasn't cost me a penny. Cost optimization. And
Sorry, what did you pay for again?
the blob storage.
Blob.
And so far, it's cost me not even 1 cent yet. Okay, then the back end. We're actually using a couple of different components, and I'll tell you why I picked some of these as I'm going through it. I picked their document database. For one, I didn't need relational databases. I'm actually a big fan of NoSQL. That's a different discussion for another day. But it was very simple for me to put a document together that tracked who we voted for and how many votes they had. And the back end, when it processes it, it actually looks for that record, that document that belongs to Superman or to Spider-Man or to Captain America. It has a little count field on it, and every time that I get a vote, I grab that record, increase that count by 1, and I save it. That's it. Nice and simple.
Why not use just the basic Azure for
Good question. I had a grand vision for this voting site. I'm making this up as I go along, but requirements, right? So DocumentDB gives me a lot of other things. We'll cover in a little bit more detail later, but the one thing is it gives me pretty much unlimited storage in the sense behind the scenes, Microsoft is handling all the servers behind me, the clusters, the geo-replication, the scaling of that application. So I don't even have to think about it. I don't have to think about my auto-scaling bits. It just grows. The other thing is I wanted something durable because I want some long-term durability on it, and it gives me a pretty good SLA on the durability bits. And the other part, and really again, it was the unlimited scalability, both in terms of storage, CPU. Let Microsoft deal with it. I don't have to learn how to stand up a document database on my own. I don't have to spin up VMs and figure out how to configure my own cluster. It was already there for me. From a business perspective, you have this grand vision of this thing that's going to grow like crazy. It's a good place to go if you don't require relational constraints. Use queue storage. And again, this was for the votes. This was done on purpose to show it off, but also thinking about it. This type of survey that we're doing, even if this thing went viral and we were getting hundreds and thousands and millions of votes coming into this, if I lost 1 or 2 in that queue process, not likely to happen, but if I did, don't really care. If 2 queues came in for the same vote and my backend process only counted 1 of those because it got invoked twice and they were both editing the same record at the same time, don't really care. It's not a big deal. It was a way for me to scale this out real easily. Another way that I could have done this is I probably could have put those individual votes as record in my document database and then had something else kind of go through and recount those every so often. Or I could have issued, in SQL, the common thing would be is I'd have a table of votes. I'd find my where and do an aggregate on that where for the superhero or the other candidate and count them and do a select on it right when I go to display them.
So there's not a clone that spawned up with a queue for each client? You're saying that you could lose votes?
I could.
Okay.
In this particular, and there's ways to, you have to be aware of the way that that queue storage works, but basically you're guaranteed at least once delivery on them. So once it's been delivered, it's gone. If for some reason my process on the back end died, there is a way to recover from that, but you have to be, when you're creating your application, you have to be aware of the guarantees that the queue service gives you and how to deal with those. But again, for this particular application, it was quick, it was easy. I can show you queue storage, something to think about.
So, I'm sorry.
Yep.
So queue storage, that's a component running on Azure?
Yeah, that's a component running on Azure. Yep.
So that's like a messaging component?
That is a messaging queue.
Messaging queue?
Yep.
Like JMS. Messaging?
Yeah. This would be the equivalent of like your RabbitMQ. Would be your equivalent of it's an AMQP compatible queue, right?
Oh, it is AMQP compatible?
It is. Yep. And it's part of the storage services that Azure gives you. So again, from a scalability perspective, the storage service, I get pretty much unlimited scalability as long as I'm willing to pay for the storage, right? It'll grow and expand, and I've got good durability. Don't have to spin up my own RabbitMQ, don't have to maintain it, don't have to configure it, don't have to worry about its security because I'm not going to say I don't have to worry. I share the security concerns with Azure, meaning as long as I've configured access to my queues for my applications, I don't have to worry about physical access to the servers, don't have to worry about whether the servers are patched or whether everything else that's there. I'm worrying about my application and my data and the security around that, not everything else underneath. There are, and I think one of them is going away. I'm not even sure which one it is, but around the server fabric, when we're talking about that and what they did around Service Bus, there are some things that are there. In this particular case, I'm just using the queue storage from the storage service that's being offered. In fact, I created one storage account and got the blob service that I'm using, the queue storage that I'm using, the file share, and the table storage all on the same account. The next component, and we'll look at this here in a little bit more detail, are functions. You guys familiar with Azure Functions?
No.
So Azure Functions was Azure's answer to AWS Lambda. It literally is, and I'll show you this here in just a second, but it gives me some inputs and outputs, and I configure what those look like. And I'll show you guys one here in detail. And then I write a small script that can either be done with a CSX C# script file, JSON, I can write it in Python, I can write it in F#, JavaScript, all those things, and it's a small function that basically processes that input and does something with that output. You guys want to look at one? I know it's code, but we can look at one.
Do you know if they support C++?
I don't think so. I don't think so. And I don't know if there's any plans for it, honestly, at this point. I don't know if there are any plans for supporting C++ and functions just yet. Yep. It supports Java. I believe it does. Okay, so if we look at these functions, I'm going to look at the first one here, which is cast vote. These are my bindings. So I have the first one here. This is what type this is. This binds it to an HTTP trigger. And basically, there's a URL endpoint. I'm basically creating an API that's saying, give me HTTP requests. In this case, I'm saying put request only, because somebody's going to put their vote at my endpoint, and the direction is going to be come in. The REQ, that's actually a variable that I named in the function that's coming in, and say put whatever context is in that request into a variable called request, short for request, right? REQ. That way I've got full access to what's in there. I have an out binding here, which is also HTTP, which I've named a variable in my function called result, RES. And this is where I can put status code 200 OK, 400 not OK, something went wrong, but I can respond to the web browser on what it's doing. I also have another output here, which is called, which is a queue. I called it a queue item with a queue name of tally vote, and it's going to go talk to that. And this connection string that's here, this is actually in an application setting that's hosted by Azure. This would be your app config file that has the connection string for that particular queue. And so what the function actually does, we'll look at it, this is probably the simplest out of the three, but it's written in JavaScript. That's fine. And it's a simple function that says, I've got a context and I've got a request. I'm going to return a response, and that actually happens here in this context area where I say context response equals status code. This, by default, it responds with just a status 200, which means OK processed. So when I call this context done, it finishes the execution of the function, and we're done. But if you look at what happens here, I'm logging, and I'm saying, hey, I'm processing a request. I check my request, and this is the request object. I check the body for a category and a candidate. So you guys noticed, you guys in the little code that you guys wrote in, you had a data category when it said superhero, and a data candidate, and you guys put in your superhero. I'm checking that those two things exist. If it does, I'm creating a queue item with that data, and I'm binding it to my queue item that I defined in the function, and I'm done. I've just written an API endpoint. This is literally all the code that I wrote. The other part, and I'll show you guys the interface here in Azure. Azure actually does for me, and then I can pull it down onto my project, which is pretty cool. I will show you right now. Whoa, that did not mean Zoom. Come on. I'm going to see if I'm true to my word. Real quick, check our costs. Man, this has been running for 5 days. And hopefully this won't be too high because it's economies of scale, right? I'm using so little of their storage that it's basically free for me. And Tim's in here too. If he sees this cost go real high, I'm going to be in trouble. But I'm sorry, they've charged me 10 cents. None of it for storage, all of it for compute time on the functions that we played with today. So it's been running for 5 days, and it's been 10 cents out of my pocket. And something that is completely scalable.
I've got an Azure environment that most of my developers are using that. We're coming near the end of the monthly release cycle. I just got it from the good
Okay. Total usage. Storage, compute time, databases, everything. Now, yeah. But neither here or there. So we were asking about the functions. So for this particular boot camp section, we had a couple things. We have our document database. We have an application insights, which again is just tracking analytics on the usage, page timeouts, live time. We have our functions storage account. We have a dynamic app settings plan, and this is one of those where, because I'm using functions and all these services where I don't actually need an IIS instance to be hosted for me, I didn't even, basically said, just charge me for the compute time and the storage. Right? So I'm not even paying the $24 a month or whatever it is for a basic app service with an auto scale plan on it because I haven't needed one. And then the functions, which was the question here, is where does this go? So where it actually sits, if you looked at the diagram, I had in there the file storage. In my storage account, there is a directory structure that was created there by functions that has a site directory with a triple-W root directory where each of the functions is an individual directory, like we saw in the source code, and it sits there. It's file storage. It's a new offering from, sorry, file share. It's a new offering from the storage services. Or relatively new. It's been around for a little bit. So again, I don't even really need all the GitHub stuff. I could actually tie this to my GitHub to do automated deployments out to this without even using Visual Studio Team services. I'm talking, this is where Azure just blows my mind. If I'm thinking just about what I have to build, I can put these components together and really quickly get something up that we can start playing with to see if we're going in the right direction, so I can experiment like crazy before I make any hard, fast decisions on what I'm going to buy and commit to actually build out for production long term. Love it.
You said this could be a C# file?
Yep, this could be a C# file, or a CSX file to be, which is the C# scripting file. It'll run, it's for the, I want to say right now it supports the .NET Core runtime, so it's a smaller subset of the whole entire, don't quote me on that because I haven't played with it too much. I've been playing more with JavaScript lately than I've looked at CSX.
Be careful what I use in writing it, because...
Not really. Go, when you get a chance, go to the Azure portal and look at functions. They've got some developer samples in there where they do C# on it. And I think it's just, you have to use portable libraries or whatnot that you're using behind the scenes because for some reason or other, it's kind of what I've seen. But yes, the question is, can I use C# here? Yes, the answer is yes, you can use C#. So there's our function. Then I mentioned the other part where I said, hey, here's the bindings and all that type of stuff. You got a UI for this. Here's my triggers. It's an HTTP request. You got some modes. You got some standard. You got your authorization levels. I can do function level authorization, admin level authorization, so I can secure the crap out of this function. My outputs, it's what I defined. I've got to respond back to the HTTP request, and I got to put something in a queue. So I configure that. I write my JavaScript file. I'm done. I've got an API endpoint. Uh-huh.
Those on the left-hand side, under authorization, right?
Yep.
So it's a level, you see anonymous. You want to select anything else, you have to set up an instance Active Directory.
No, it's going to be tied to, and again, this is brand new and it's in preview, so I'm going back for this. If I do it in the function level, this is actually going to put a key in the query string to make sure that whatever's talking to it at least knows that key. It's kind of a shared key type of approach. The admin one, I got to be honest with you, I don't know. I haven't looked at it. I want to say that it's tied to the directory service in Azure, which is if it's linked to your Active Directory, you should have that in there. But I didn't play with that just yet.
Right. But not right now, anybody can access the website as a whole. It's not by user. Meaning the website, the third-party plugin.
Right. And so we could actually wrap this with either a web app service or I want to say even an API app around it to actually do the authentication stuff and whatnot to make sure before they hit the APIs and then pass it through. There's a couple different tricks that we could do that to lock it down.
Right, so when it's logged in, they only see their port versus everyone else's port. That's one per user.
And that's going to be around the application design as well too. So like for example, what would I do differently? Rather than making a simple index HTML file, I might actually write an MVC application that handles the authorization and passes some additional parameters to the API, or that configures the client to pass some additional parameters to the API so that I pull the right data, right? The surveys that belong to that customer or the votes that belong to that person, that kind of thing. That would be a production level thing. Right, exactly. Yeah, this is more, again, this was a prototype that I slapped together, and Tim's going to want to know this because he's going to know how much time I spent doing on this. But I think, in time of putting the application together, I think I maybe spent 2 hours on it.
Wow.
Setting it up, putting it up in Azure, creating the GitHub accounts, setting up, I probably spent another hour setting up the build, making sure that it all worked, and maybe another hour doing a dry run of what we were going to do in the lab today. But total time probably spent on it was about 4 hours. 10 cents in 4 hours. So in all of these get a little bit more different. And we've got a JavaScript developer in here. Are you using Node? Yeah. Okay. So you'll love this because you saw that this was Node. The category results guy, this is actually using Node. I actually have a couple other things around it, which are the, let's go to the code real quick, and you probably already saw this. But in this guy here, I needed to use more than what Functions gave me. I actually needed to pull in another package from NPM, that's the Node Package Manager, which is kind of like the equivalent of NuGet for C# to pull down a package that has how to access this. And so you'll actually see on the category results, I included a package.json, which is used by NPM to figure out what dependencies I have. And I have a dependency on the document.db npm package, and I want the latest version. So I actually took this file here, deployed it to the file share, ran the npm install command, and that gave me access at runtime to use the full power of Node in that particular function. Right now, pass some parameters in there to call the document database, tally, get the votes that we're going to send back, and respond with an HTTP request back out with the vote results. Kind of gives you an idea of the architecture here used for the application. It's very simple, but again, I was thinking small, bite-sized pieces to get something off the ground quickly. How can I put it together to compose something? Add another question in here too about Git merges. How do you make sure that you do? So this is where it comes in with the application architecture. As a team lead or as a development manager or software development manager, I'm going to work with my team to say, hey, we've got some changes to the UI. Who wants to take those on? Right? Nitesh might say, yeah, I think I can handle that. I've been playing with Bootstrap. I want to take that on. So he's going to work on that file. And I've got that in my head. And then I can go to somebody else and I can say, hey, you know what? I know that the tally vote function has been kind of chugging through the queue items, and we've been losing a higher amount of queue items than I would have expected. I need somebody to go and look at that. And that might be Javier, who says, you know what? I think I need to look at this from an architecture perspective, make sure we pick the right services. So he's going to go work on that. And now, it's more about the distribution of work that keeps us from doing that. The sample that we used today, because I had everybody go and change the same file in the same line, that's why we had 4 or 5 merge requests. So it's more about organizing the work into small bite-sized chunks that'll make it easy to avoid those Git merges. And I promised you guys a GIF, and I didn't get to it because pressed for time. So let's go back real quick to our presentation here. Okay, the other things I didn't talk about. So we talked about functions. I'm also using table storage, again, from the storage app service for API logs. It's used by default by functions. So when functions kick off, you guys saw in the script, I said context.log, and I put some information. That's where that's going. And I can put some retention criteria around my tables to keep the logs as much as I need to. I can do a lot of stuff. But that's our architecture here. File share, this is actually where the code for the functions is actually stored. So the function.json files, the package.json files, the index.js files for each of those is where the functions are actually stored on the server.
Is table storage relational, or it's just, what is stable? I mean, it's not a block, it's not a log.
No, it's slightly different. Think of it kind of like an abstraction around a CSV file.
Okay, got it.
Yeah, it's designed just for quicker access. I mean,
So it's not text, it's for limited text.
kinda. I've honestly, in all my years of working with Azure, I've never actually used it directly for an application because it's a lot more functional for logging. So like sys logs, application logs, and that kind of thing. It's very, very commonly used for that.
You can search it, sort it.
It's not a database. No, it's not Excel either. That's what I said. It's very much. That's why, in my mind, it's like an abstraction around a CSV file. It's kind of flat and kind of just a file search. It's not very smart. It's just a different way to store your data. All right. So that's what we did application-wise. So architects, when you guys are thinking, how am I actually going to architect this new application or transition my existing application out to the cloud? I'm going to present these slides kind of like an order of operations of what I'm thinking about before, as I'm selecting components to start building this out to figure out what I can leverage. And again, I'm thinking microservices, so looking at components that I can slap together that we can test out, validate, and then grow and expand if they prove out. So the first thing that I'm picking today, and I know it's a little bit bleeding edge, but serverless. Okay? If I don't have to worry about the app service plan, figuring out what my scale up and scale out conditions are. Are they CPU based? Are they RAM based? Are they I mean, you've got all these different variations that they can get some very complex plans to get that elastic scalability. If I can pick services that just work, and I only pay for the function, the CPU time, the RAM time, the storage time, 10 cents for 5 days, type of scenarios, I'm all over it, right? I've got no IT overhead. I don't have to patch any operating systems. I don't have to worry about configuring plans and lots of application settings. It's literally write my code and go. Slap them together, work on it. Yeah, I get those. And remember what, you weren't here this morning, what Jim said, it's, sure, we can do anything as long as you got the right money to invest into it. Okay, I'm all over it. Grant.
Now, I asked a detailed question at Amazon about their Lambdas.
Mm-hmm.
And the Lambdas aren't ready to go when you hit them. It takes time to spin them up. And then maybe if you just used it, it'll stay in memory. But it's much, much slower than a server.
Yep.
So do you know the performance characteristics and caching of functions?
Very similar.
Yeah.
It's very, very similar. So actually this morning, and there's a couple tricks that you can do to this to keep them going. So I worked on this on Monday late at night after a long day of work. I needed to start working on this because that's, put things off to the last minute like every good human being. But I'm working on this and I'm going, okay, put some stuff together, got my function up there, got the index HTML file kind of going. Then I got tired, went to bed, got up the next morning and said, I'm going to go check this. And I went to go load the page and the index page came right up, but it also has that function call to go get me the results. And that took a good 20, 30 seconds before I saw the first one. I was kind of like, that kind of sucked. Then I hit refresh and it came right back. And I was like, okay, now we're good. But that's your spin up time. And the trade-off from here is because since I'm not reserving that power and I'm trying to optimize my costs, if it's not being used, Microsoft's going to do everything possible to scale it down as much as possible to reduce their costs. And once it's being used, it'll spin back up. So you know what I did? I installed Application Insights, and I ran basically a availability test that runs every 5 minutes and pings my web page. So now it's never spun completely down. This time when I brought it back up, the first time I think it took maybe 2 or 3 seconds for the first one to come up, and then it was pretty snappy after that. But that was enough for me to say, okay, they spun it down enough to where I can live with it.
Do they charge you for that?
Well, yeah, because since I called that, I'm also making an API call, right, which is costing it. So to be completely honest, this was a trick that I did just the other night to see what it would do. I checked my cost that day. I was at 2 cents, and now I'm at 10 cents. So it did start going up faster because of the compute time. But it's one of those where I can kind of balance it saying, hey, if I don't want to be in that situation where I want a customer to wait 30 seconds before they get their initial page load because we've been sleeping all night, I'm willing to pay that extra, well, Tim's willing to pay that extra 8 cents.
So are you controlling that tear down and build up with Microsoft?
It's pretty much Microsoft, right? I'm relying on them doing that. And they're going to, again, for me, the compute time is flat. I'm paying for the consumption. If my users are using it, I'm paying for the CPU time. And I think I'm also paying for the RAM time, and that's really about it. And it's on a per request basis. So when that API request gets called, I'm getting charged, and it's a small cent. If I'm not using it at all, I'm not getting paid at all for even having or I'm not getting charged at all for even having my code running up there. So they're spinning it down as much as possible to manage it. That's a trade-off.
I think what we're using what? Redis cache API calls.
I'm not even using Redis cache. I'm not. I can, but I didn't plan.
No need, okay.
Yeah, there was no need in this particular one. Could I have done that? Yes, I could have. But the issue that I saw with it is it wasn't when I really looked at it, it wasn't the issue of could I get the data fast enough because document DB was sleeping. It was the function call. So it was the API call that was slow. So even if I had Redis cache here, it still makes the API call first. The API would call Redis before it calls document DB. So it's still going to be slow. So that's why I was like, no, I'm not going to throw a cache in there.
Okay, so an advanced question.
Yep.
Lambdas are extremely limited in what they can do outside. For instance, we tried to write a Lambda to hit a socket or something like that, and it simply was blocked. So you know if these and you may want to hit an external database.
Sure.
Maybe you don't want to put your database in Azure. You want to put it on somewhere else. So you happen to know, and this would you can say no if you don't know for sure, but these functions, what sort of security is around them, and can you go out and create sockets? The only thing Lambda seems to allow is HTTP, nothing else, apparently.
Yeah. So the question was around around function security, meaning what am I able to do, establish other connections beyond the standard HTTP ports or the ports that are provided for Microsoft. The answer, honestly, is I don't know. I haven't really tried it. However, I expect it to be exactly the same as Lambdas. Remember what I've given up. I don't control most of the security. I don't control most of the infrastructure and the architecture. So router configurations, switch configurations, server configurations, virtual firewalls on the individual servers that these are running on are pretty much out of my hands. And so I know for sure that I have the bindings that we saw. What can I connect to outside of the world? I have HTTP, HTTPS. I have the database connections that are, I wouldn't be surprised if they were saying within the Azure scope, right? So kind of like a DMZ to a private subnet. And it's going to be pretty much limited to that. I wouldn't be surprised. I don't know for sure, but that would be where I guess. And so again, this is one of those where, from an architecture perspective, I'm going to try this first. If I run into something like that doesn't work, I'm going to test that. And if it doesn't work, okay, I'm going to look at another option. But I'm going to start here. This is where you're going to get the biggest bang for the buck, the most scalability at the lowest cost coming together from an application perspective. Next thing that I'm looking at is I'm looking at services that I can use to compose together that give me horizontal scalability and increased availability. So this is going to be around using app services, right? So I can create an app service plan that has at least 2 instances that I can spin up to 5 or 10 based on some conditions. Logic apps, mobile apps, and API apps all fall under this. Takes me a little bit more time to set them up. There's a little bit more commitment involved with it. I think the basic standard or recommended app service plan starts at $24 a month. And it can be a shared plan across multiple applications if you want it to be. But I'm making a monetary commitment of having these services available for me. So there's a trade-off there. And it takes a lot more configuration on my time, which means I've got to be more familiar with it. I've got to be more in control. I've got to know more what's going on there before I can kind of let things go out into the wild. But all of these services will give you some sort of scalability, elastic scalability with pretty much zero downtime based on your configuration parameters. So you're talking the app services, SQL Server database, SQL Data Warehouse, Redis cache will work along this too. Azure Container Service and Traffic Manager all work together to provide that scalability. What I don't want to do, and this is, again, the common, and this is really, if you're in the cloud, stop guessing at your capacity needs. Just stop it. Come on, architects. Don't think about buying servers and ordering and how much capacity do I need, and take a guess, go make a huge commitment, and be wrong. Because if you order too much, that's money you could use somewhere else. Additional operational costs, development hours and whatnot, capital expenses over OpEx. If you don't order enough, you have a Black Friday where you lost sales. Sucks either way. So stop guessing it. Use these types of things if you can for your custom applications.
How easy is it to do auto scaling?
Pretty easy.
Azure. I mean, if you just buy one server, it's not that bad if you can auto scale.
So it's a little bit. Are you trying to compare it to AWS? Yeah. Okay, so it's a little bit different. If you're in, so these are going to be around the managed services areas, and you're actually going to put it's similar to the auto scale group in the sense that you're putting limits, upper limits and lower bound limits on it. So if I have a shared average CPU utilization of 75%, spin up another instance. You can put rules around it. If the average CPU load across my number of instances drops below 20%, turn off an instance. And you can do those kinds of things. That's all included here. The part where it gets complicated is, and this is also true in AWS, is if you're running this in just a virtual machine environment or an EC2 environment in AWS, is you also have to make sure that as these new VMs spin up, that they have the right components on there. So you're going to be looking at using Azure Container Services. Is kind of like using Docker and those kinds of things to make sure the right components go out there. Making sure you've got the right images saved to use as a startup process, the right scripts enabled to automate the spin up of those environments, and making sure that your application is stateless to be able to talk across that particular group. And that's a common thing. You're going to spin up additional VMs, put them behind a traffic manager. This is your load balancer, and add them to that particular group to be able to be available for your customers.
Azure Container Services is like VMware?
It's Docker. I don't know if you're familiar with Docker. So Docker's, I'm not gonna go too deep into it because we're down on time, but it's a way for me to put together the definitions of certain machines and their roles and the components that go into those machines, so I can automate additional provisioning on them based on certain criteria. Right, so you create your Docker definition, then you create what's called I think it's a swarm, or I forget what it's called, but it's basically you're defining the farm and the ratios it should have of certain types of VMs to bring them together to orchestrate a much larger system. Yeah. So unless I have historical data, Greenfield's the hardest. I have no idea. Is this going to go viral tomorrow? Is it not going to go viral tomorrow? So again, Greenfield, I'm going serverless first because then it doesn't matter. I have virtually unlimited scalability based on its adoption. If I've got technical reasons or other reasons that say, no, you can't do that, we're going to go to some of the managed services, I'm going to start with not a basic plan, but the lowest cost standard plan. And I'm going to put some auto scaling policies around that. All right. So for instance, you've got your S0 plan, I think is the basic one for app services. I'm going to set it up with 2 instances at a bare minimum because I want some availability to be set up. And I'm going to set it up to where every time that the average CPU load on that server hits 50% for more than 5 minutes, I'm going to spin up another 2 instances. Right, and I'm going to slowly start incrementing that size. And I think with the standard S0 plan, and this is where it gets tricky, you can scale out to up to 10 instances. So then comes the other side of it. If I'm getting close to those 10 instances, what I actually need to do, and there's an auto-scaling policy for this, is scale up. Which I'm saying, okay, instead, if I can't scale out anymore, I'm going to go up a level, which means upgrade me to the next plan, which gives you more CPU power per instance. It gives you some additional RAM per instance, some additional storage. And I think as you keep going up, you also get additional scale out capabilities as well too.
So that's your methodology, have to scale out first and then scale up?
I'm going to use the lowest cost plan. I'm going to scale it out as much as I can. If it's insufficient, I'm upgrading. Scale it out as much as I can, go to the next one. And because every time that I go up, my cost per instance is going up and my commitment's getting bigger, right? So but the important part is don't just think about scaling up. Remember to scale down. And so this is actually a really good example for development environments. Jim was talking about taking advantage of big corporations when their office hours are down, after hours, weekend times. Your scale down plan is just as important from a cost management perspective as your scale up plan. Meaning if that CPU and that load works, scale in and down, in and down, in and down until I'm back to that starting point at my lowest cost. Right? And the idea here is I'm not going to guess my capacity. If I've got an e-commerce site and Black Friday hits, I am not losing a customer. And management will not complain because of the revenue that's going to be coming in. But if it happens to be some other day throughout the year and our website has seen 1 customer per hour, I'm not keeping 100 servers up. No reason for me to do that. We got about 5 minutes left, and I've got about 3 more slides, so we're power through real quick. So architecture-wise, again, that's how I'm doing my component selection. That's how I'm keeping scalability in mind and where do I start. And remember, scaling down, in and down is just as important as scaling up and out.
Let me just slow you down.
Yeah.
What's the difference between a web app, and a logic app?
Good question. So this is going to be for hosting your web application. It's your MVC site. It's hosting your basic ASP.NET type applications.
It's like a PHP server or Node server?
It's an IAS server, for lack of a better term, with ASP.NET on it. Logic apps are actually designed more to be back-end type services, so event-driven type services, batch processing. Think of I might have this would actually be a good one. We have our voting app, and our voting app is receiving hundreds and hundreds and hundreds of votes as it's going through. If I didn't have functions, I could have probably used a logic app to listen for those queue messages coming in to process them and tally them. So it's my back-end processes that are kind of sitting out there, not web-facing. A batch daemon, yep.
And I also believe that are used for PBM, business process management, some application uses BizTalk.
Yep.
Use the BizTalk
Not BizTalk. It's using Flow, which is another one. So it's you could have other workflow components that kick off a logic application, and so it's doing that process management, batch process management for that particular thing. So again, I'm guessing you're coming from the AWS space. You've got oh man, I'm gonna forget the term. Not data pipeline. It's gonna be different, but they have SWF, Simple Workflow Service. Okay, the simple workflow service could be pointed at a Lambda function that performs that batch operation. It could also be pointed at calling an endpoint on an EC2 instance that performs some other service. It's going to be the equivalent to that, of saying, hey, something else kicked off that logic app. But it's going to be event-driven, either by manual start of a workflow, an automated part of a workflow, data coming in somewhere that sends an event somewhere else. It could be a notification that's received. It could be processing email, a number of things that could do that, but it's your back-end processes. Mobile apps, these are going to be for hosting your Xamarin-based apps and things where you actually need a backend. It's really just APIs for a mobile application. You've published your app on the Apple Store, on the Google Play, Android stores that are out there, and you need a backend to communicate up to and to push updates, not to the stores, but anything that would be internal to the application that can be updated. That's where you would manage it. And last but not all is the API apps, and this is really around building applications to build wrappers around other cloud services and exposing APIs to your applications as well too. So they're kind of, you can mix and match these, but they kind of have slightly different functions in the way that they work. And what you're really doing in these is you're grouping your applications into the right area where Microsoft can price and manage it for you with the typical constraints that they deal with. So for example, the logic apps, probably not going to be a web-facing thing, and I never have to serve pages, right? It's going to be triggers coming in, inbound communications. So now they can optimize the infrastructure behind the scenes for those applications to provide you with that managed service. You got it. All right. Reduce operational complexity. So you've got a ton of services are out there that are what would be considered advanced technologies for most IT organizations. Like I don't know too many organizations that actually have IT folks who know how to spin up a Hadoop cluster, who know how to configure HDN site. Heck, some of the analysis services that are available today in the common products can be complex for a lot of organizations that have never seen them before. So everything that we do and we think of that's out there, we've got to think about all these other services that are available to us to help accomplish a certain task, and realize that by choosing them and going cloud-wise, we're reducing our operational complexity and overhead from that perspective. So make it easy. If you've never worked, so I could go through these if you guys know what they are, but some of the things that a lot of people don't always touch. Batch processing, this is going to be for large parallel processing, MapReduce type of functions and things that are out there that you can do. We talked about document database already. Redis cache, again, it's another caching layer you can introduce. It's a key value store. It kind of goes along with the NoSQL, but it's really, really, really fast, like lightning fast. Media services is going to be for encoding and transcoding. I know Mick had some experience with media services. It's kind of fun. Search. I'm trying to remember what they use behind the scenes for search. I know AWS uses Elasticsearch. Can't remember the Azure one as well too. But setting up a farm for just search services can also be a complex thing. It's available for you there. Mentioned HD Insight, machine learning, cognitive services, and then you've got the bottom three, which are really around IoT type things. If you don't know what any of these are, just know that they're available to you, and take time to go out and find out, because there's tons and tons of new advanced services that are coming out there that you can spin up and experiment with as part of your architecture and development process. Start thinking, okay, somebody asked for voice enabling my app to say when I talk to my app that I want it to be able to respond to me and to do things for me. So such as I'm driving down the road, I hit the talk button and I want it to record an expense for me. I think Expensify is now doing this, which is kind of cool.